recording here. Okay. Cool. Good morning. Awesome. Okay. So first things first, right, on our Moodle page, I posted the 1.3 solutions. So in the notes, right, there were all these questions, and I've been saying, I gotta find the solutions, I gotta find the solutions. And so I didn't find them, but I kind of put them together. And so here are all the solutions. You'll see that it kind of works through, so I don't have a pointer on this page, but it kind of works through a couple of different steps. They've tried to make it as small as possible, right? So it is quite condensed. But that might be good for when you're practicing this stuff, especially when we get into 1.3, it's a little bit harder, right? Or when we got into 1.3, it was a little bit harder. But then also I posted the fundamentals part 3 that will start this week. In fact, I'm kind of jumping around a little bit between 1.4 and 1.5. But before we start talking about that, I want to go into our notes, start a fresh note for today. Math 120. So one thing was that the free trial of WebAssign ran out, and so I think it caught some people off guard because I had quite a few messages about I don't have it, and so that's okay. We need to get that sorted out. But what I did was I extended the due date until this Wednesday, right? So I extended the due date for 1.1 and 1.2 until this Wednesday, which is this, I guess it's tomorrow, September 30th, at midnight again, right, or 11:59. And I prefer a 24-hour clock, so 23:59, just so there's no confusion. Okay. So you've still got a little bit of time, but because our free trial ran out, you will have to buy WebAssign, but we will be using WebAssign for all your assignments and all your tests and all that kind of stuff, so it will be used, so don't worry. Whatever you do, just get the $74 one, plus tax, obviously, either through the bookstore or through the link. Okay. So let's see here. As a quick review, I submitted that assignment in between, so what should I do? Oh, well, if you're done the assignment, then you're done the assignment. Then you don't need the extension, right? It's just if you have a hard time logging on or whatever, that's fine. Just giving people some extra time. But if you're done the assignment, if you didn't complete it, then you can go back and complete it. Right. So from last week, we kind of finished, we talked about factoring. Cool. We talked about factoring, and there were a lot of ins and outs, and we'll see factoring again today. So we'll keep factoring today, but in terms of review, right, we talked about factoring. And then, so that's from 1.3. And then we talked about the domain of an algebraic expression, which is from the start of 1.4. Now, there were some things for the domain that we started talking about, saying, okay, well, we can't have any illegal math. If there are any inputs or any x's typically that result in illegal math, then we have to pull them out of the domain. Remember, the domain is all the possible inputs, right? The domain is all possible values of x, right? Or inputs. The variable isn't necessarily x, right? It can be y, it can be s, it can be t. Right? But one thing that we need to know is we can't divide by 0. And we can't take the square root of a negative number. We can't take the square root of a negative number. Okay. So just going back to our notes from last day here, we worked through a couple of these. We worked through 7, 9, and 11 from here. And what I'm going to do is let's work through number 14 just to kind of finish this off, right? Because we did 7, 9, 11, and then I want to do 14 because it's a really good one. So that's kind of the end of our review, and we'll start with an example. Find the domain of this little guy. Root 2x over x plus 1. There are a couple of things we need to keep track of here, right? First thing, I can't divide by 0, and because I have a fraction, right, I can't divide by 0, so x plus 1 can't be 0. So, can't divide by 0. So x plus 1 cannot equal 0. Okay. Which, if we just treat the not equal to as an equal sign for now, we're allowed to do that. We'll talk about inequalities in a later section where there are some things that we need to keep in mind for inequalities, but for now, in general, we'll just treat inequalities as if they're equal signs. And that's not quite correct, but it works for what we're doing here. And when it comes time, then I'll give you plenty of warning. So if x is -1, then I would be dividing by 0. -1 plus 1 is 0, then I'd be dividing by 0. So in my domain, I cannot have x equals -1. Okay, here, I can't take the square root of a negative. So 2x has to be greater than or equal to 0. It's allowed to be 0, right? The only problem that if I can't have the square root be 0 is if the square root is down here in the denominator, because then I would be dividing by 0. But in general, the square root of 0 is 0, so I'm allowed to have 0 up top. So if 2x has to be greater than or equal to 0, just treating this inequality as if it's an equal sign, then I can divide both sides by 2 and I can have x must be greater than or equal to 0. Okay. Sorry, so stuffy. Yeah. Good thing we're not together. All right. Even though I'm pretty sure it's just allergies, but who knows? It's just allergies. So here, I have a condition that x has to be greater than or equal to 0, but I also have a condition that x can't be -1, right? So in order to find the combined domain, right, the overall domain of this thing, what I do is I figure out what the overlap is, and the overall domain is that overlap in the individual domains. So this would be an individual domain, and this would be an individual domain. To find the overall domain, we need to find the overlap, the overlap of the two individual domains. My printer just started. Weird. So, what I'm going to do, what I find helpful is if I just write a little number line here, I've got some key numbers to go off of, right? I'm talking about -1, x is -1, and something in terms of 0, okay? So I'm going to put those on here, 0, -1. And then what I'm going to do is I'm going to take the x can't be -1 and draw that as if it's a number line, right? So here I'd have an open dot at -1, and then it would just keep going in either direction. Everything else is allowed except x equals -1. For the square root one, I said x has to be greater than or equal to 0, which means I'm going to have a full dot at 0, and then everything to the right of it is allowed. So here is my domain for that square root. So now all this overlap, including 0, right, because it's allowed to be 0 on both domains. So now everything from 0 and everything greater than 0 is in the overlapping domain. So therefore, the overall domain, actually, let's do it in a different color here. Oh, dropped my pen. Therefore, the overall domain is, and remember set builder notation, the set of x's such that x is greater than or equal to 0. Nice. That's great. Okay. So that was a little bit tricky, and we will deal with more domains later on. But for now, we're going to parking lot it. And if we go to the notes, and let's see, go back here. Oh. Right, this is where we finished off here. This is the one that we just did. This is the example we just started with. So that's the domain. We're going to put that to the side a little bit, but it's going to come up, definitely. So, but what I want to do is, before we go into simplifying rational expressions, so a rational expression is anything like this, right? We have to talk about factoring, and they kind of do it the hard way, where they don't introduce the quadratic formula until section 1.5, so the next section. But what I want to do is I just want to make our life a little bit easier and show you how to factor things using the quadratic formula. So here, right, if we have to simplify rational expressions, if we're multiplying two expressions here, then we can factor both the numerator and the denominator if we can. And then ideally, just like factoring before, factoring is so that we'll be able to cancel stuff, either from the denominator or from the numerator, or potentially both, right? And so we want to be able to cancel stuff. but it means that we have to factor. Okay? So what I want to show you guys is kind of an easier way to factor something like this, x squared minus x minus 2. So something that doesn't follow the rules that we established last day, right? Those, the factoring, the special factoring formulas, or if we have more than 4 terms, we're able to group them potentially and factor that way, or just pulling out a common factor. That would be the easiest thing to do, right? So if we have something like this, this is called a quadratic formula. So I'm going to show you how to factor something like that easily, right? Here they're assuming that you're just going to go through and you're going to do it, and it's going to take forever, and well, potentially not forever. If you're good at factoring, then that's great. But for me, I'll always use the quadratic formula for these things. So, and then we'll keep going with multiplying and dividing rational expressions. But what you'll see is because we know how to multiply and divide fractions, and adding and subtracting fractions, we also know, so because we know how fractions behave, now we're just talking about algebraic expressions instead of just numbers, but the ideas stay the same. So what I'll say here is the remainder of section 1.4 will be easier to do if we introduce section 1.5 first. Right. So here I'm going to do a little switcheroo because I went through it and I don't know, it just wasn't very nice. So in section 1.5, we will see, I'll call it a shortcut. You'll see sometimes it can be a little bit long. A shortcut for factoring expressions of the form ax squared plus bx plus c often will have equals 0, but it'll have this form. So something times x squared, and that something can be 1, so then you just have x squared. And then bx, so something times x, and then plus a constant. So if you're starting to recognize this form, right, if we look back at, maybe I didn't pull in those questions quite yet, but if you look back here, a lot of what's going on here, so this one is of that form, x squared minus 1 is also of that form if you let b be 0. Same form, and we call this the quadratic form. So quadratic, 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 quadratic can be tweaked into quadratic, quadratic. Here we have next to the 3, so we cut it out because I don't want you to have to deal with that. Okay, so let's go into section 1.5. We'll do section 1.5 before we go back and finish 1.4. Can be confusing, but section 1.5 is in your fundamentals part 3 that I posted on Moodle. Okay. And first of all, it goes through and it introduces the idea of equations, right? So an equation is anything where we have an equal sign, and we should be very comfortable solving equations, right? And so all this is just kind of for extra knowledge. For us, where I want to start is just solving for different variables in an equation. Okay. So 1.5. Oh, 1.5 equations. We will start by looking at solving for different variables in equations. So first thing we're going to do is we're going to have a look at some of these and solve them. Okay. We'll start nice and slow, right? Let's do 31, and then I think I picked out 34 just because I like what that looks like, and then we'll see how we're feeling. Okay. So for 31, someone walking around outside who looks lost. 31, we have PV equals nRT. Oh, good, you heard me. And we want to solve for R. Okay. So what we have to do is we have to hold this R steady, right? And we want to get R on its own. So we want to isolate R, and we have to kind of undo what the N and T are doing to R in order to get R on its own. So if N and T are multiplying R, then to move them to the other side, we have to divide both sides by N and T. Right? And so what we have is we have PV equals nRT. And then what I'm going to do is in light blue, I'm going to divide both sides by n over t, because what I do to one side has to happen on the other side as well. Right? And I'm not going to show all these steps always. I just want to show them so that you see what's happening. And I'm trying to use a different color, but sometimes I might forget. This n and this n cancel, and this n or this t and this t cancel, right? And that was the whole point, was to try to get R on its own. I can only cancel because I'm multiplying, right? So now I have PV over NT is R, and now I've solved for R. Right? What if we did, so we did that one, what if we did 34? Okay, 34 is a little bit harder. If I have 1 over R equals 1 over R1 plus 1 over R2, and I want to solve for R1. Give that a little go while I have some water. A little tickle in my throat. See what you can do. Because this is only our second one, I'll kind of walk you through it. Right? If we're solving for R1, R1 is different than 1 over R1. Right? So we're not solving for 1 over R1, but we're trying to get R1 on its own. So what I want to do is I want to hold this guy steady, 1 over R1, and I'm going to move the 1 over R2 over to the left-hand side. Right? However you want to make that switch is fine. 1 over R, and then I'm doing minus 1 over R2 on both sides equals 1 over R1 plus 1 over R2. And of course, same thing on this side, 1 over R2. 1 over R2 minus 1 over R2 puts me at 0, and that's why I did it, right? To move it from this right-hand side over to this left-hand side. So those go away. So now I have 1 over R minus 1 over R2 is 1 over R1. I want to solve for R1 though, so I need to tweak this a little bit, right? So what I can do is I can multiply both sides by R1, which would bring this R1 over here, just keeping in mind that I'm multiplying both of these terms by R1 now, so I'm going to have to use brackets, otherwise it won't work, right? So what I'm going to do is I'm going to have R1 times 1 over R minus 1 over R2 equals 1 over R1 times R1. Sometimes people like to have kind of the same format, so the thing that I'm doing over here, the times R1, you could have put it here just as easily. I put it on the left-hand side of the brackets. It really doesn't matter, right? A times B is the same as B times A. In general, if I'm multiplying something over, I like to just put it on the left-hand side so I can see it. But that's just, I'm just letting you know what I'm thinking and doing here. 1 over R1 times R1 is, can cancel this. Seems to be frozen because it's, my screen's not catching up. There, hopefully we're good. So it got caught up. I haven't had it freeze yet. That's so weird. Anyways, something to keep track of. Or I haven't noticed it freezing yet. So we multiplied by R1 so that we could cancel on this side. Notice that I'm still left with 1, right? R1 over R1 is still 1. So we have a 1 over here. And then now I have R1 here. So now I have R1 times 1 over R minus 1 over R2 is 1. On both sides, I am going to divide both sides by this whole chunk, right? So just remember that this, you treat this as one thing. So everything inside the brackets is going to move over. Yeah, that's the right one. But we're going to mark the whole chunk. So what I'm going to do here is I'm just going to 1 over R minus 1 over R2, and then do the same thing on this side, 1 over R minus 1 over R2. These guys are going to cancel. So what I'm left with, right, is R1 on the left-hand side. So R1 equals 1 divided by, because notice 1, and then there's space here because I had it taking up the fraction taking up 2 spaces here, but 1 divided by, and then this whole thing. 1 divided by 1 over R minus 1 over R2. Good. Oops. No negative, that's just a stray pencil mark. Nice. Okay. I would say that this is simplified enough. We definitely, by the end of today, or kind of the end of 1.4, we'll be able to simplify this a little bit. Right? But for now, we'll just leave it. But it would involve common denominators, right? You'd have to find a common denominator. Treat this as a fraction divided by a fraction. and then flip and multiply, right? But because we kind of skipped that, and then we're doing 1.5 first, I'm going to leave it for a little bit. Okay. So let's have a look at some of these other ones. Are there any others? I want to leave quite a few of them for you guys, but the next one, or the last one of these that I want to do is 42. And just showing you a couple of different options that we would have to deal with. And then the rest of them you can use as practice, and I'll post the solutions. If A equals capital P times 1 plus I over 100 squared, solve for I. Okay. Here, I is way in the middle here. And so what we have to do is we have to slowly kind of peel this onion and get at the I. But we have to do it using the rules of operations, right? And so we have to first remove the P. So to remove the P, we have to divide both sides by P. Then I have this chunk squared. So in order to get at this chunk, I have to take the square root of both sides. Then I have to subtract the 1. Then I have to multiply both sides by 100, and only then am I left with just the I, right? So it's going to be a multi-stage process. For this one, I'm not going to show what I do on both sides. I'm only going to do it to the side that things are moving to, right? So if I'm moving the P over to the left-hand side, I'll just show A over P in the next step. So I've got A over P is 1 plus I over 100 squared, right? So I'm picking up the pace a little bit, right? So you want to be careful. So now the next thing I'm going to do is I'm going to take the square root. So when I write this here, I'm going to have the square root of A over P is 1 plus I over 100. The square root of something squared is just itself, right? So really I could remove these brackets if I wanted to, because they're not doing anything, right? They're not multiplying, they're not being squared. So I just have 1 plus I over 100. So trying to get I on its own still, I would have to subtract both sides by 1. So I've got the square root of A over P minus 1 is I over 100. Finally, to solve for I, right, I have to multiply both sides by 100, just being really careful that you're multiplying this whole thing by 100. Okay. So what I have is I have 100. So same thing, I like to have if I'm multiplying, I like to put it on the far left so I can see it, times the square root of A over P minus 1. Notice also that I'm putting a little lip on the square root because I really don't want to get confused later and say, oh, is this A over P minus 1 and then square rooted? Because that's going to be way different, right? Just remembering that we're only taking the root of the A over P and then minus 1 equals I. And then just as a little side note, right, usually I always want to have what I'm solving for on the left-hand side, right? But you can kind of treat it as a revolving door. If A equals B, B equals A. So you can swing things around the equal sign and it'll still be true, right? And so usually I like to write equations or write the solution with the variable I solved for on the left-hand side. Okay, so just recall A equals B is the same as B equals A. Maybe I'll, there. Little squished. Right? So how I'm going to write this is I equals 100 all times the root of A over P minus 1. Okay. But those two things are equivalent. Okay, nice. We can do this with just equations involving x as well, right? And so if we go to the notes from 1.5, when I say we want to solve an equation, right? What I mean is solve for x if it looks like anything like this, right? So if there's ever just one unknown and I ask you to solve the equation, it just means figure out what x makes this true, right? So here, solve the equation. Solve the equation means solve for the unknown variable. So in all of these, right, I've got an x, 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 x. I'd have to solve for x, solve for y if there's a y instead, it doesn't matter. We can even have t's and sometimes we have s's. Just depends on what we're talking about, right? So if you have to solve the equation, it sounds cryptic, but really what you're doing is you're just solving for that unknown variable. Okay. So let's see here. Let's do 18. So 18 has 2x plus 3 equals 7 minus 3x. If I have to solve this, right, solve this equation, what I'm solving for is the x. There are two x's, 2x and negative 3x, but with a little bit of work, I can collect like terms and I can solve for 1x. Okay. What you'll want to get really good at is just kind of looking at this thing and seeing what's going to be easier to do. Either way, you're going to end up at the same answer, right? What I mean by either way is you have two options. You could collect your x's on the right-hand side, meaning you'd have to move your constants to the left-hand side, or you could move your constants to the right-hand side and your x's to the left-hand side, right? I don't know about you guys, I don't like dealing with negatives. I find that they're kind of annoying, so I try to avoid negatives if I can, right? So just looking here, if I had to move this 2x over to the right-hand side, well, then I would have to subtract 2x from both sides. So then I'd have negative 3x minus 2x, making a negative. Same thing if I had to move this 7 over to the left-hand side, I'd have to subtract 7 from both sides. So then I have 3 minus 7. fine. I've got a negative equals a negative. They can cancel, but in general, I like to avoid it if I can. So what I'm going to do is I'm going to move the negative 3x over to the left-hand side and move this 3 over to the right-hand side. So what that's going to look like is I'm going to have 2x plus 3x, right? I have to add 3x to both sides. And I'm not going to show that work. I'm just going to show it as 2x plus 3x equals 7 minus 3. Right, maybe I'll show it here. Minus 3 and plus 3x. Because now what I have is 2x plus 3x, which is fine, that's 5x, equals 7 minus 3. 7 minus 3 is 4. So then what I have is, if I'm solving for x, then I've got, I have the 5 multiplying the x, so I have to divide both sides by 5. So then I have x is 4 divided by 5. Okay. Just saw our fresh grass rolling. 30, well, I might, so Tushar asked if we could do 30 as well. I might let you try it on your own because I want to get into quadratics really quick here. Okay, we'll see, but we might be able to come back to it. But I do want to get into quadratics. So, and I'll post the solutions. But what we mean here is that x equals 4 over 5, right? This is a solution to 2x plus 3 equals 7 minus 3x. So what that means is if I plug in x equals 4 over 5 into both of these x's, they should end up at the same value, right? So just to check our work, right? Let's go through and plug it in and see where it gets us to. To check our answer, I'll be right back, but start plugging in those values. So the x equals 4 over 5. Sorry. Okay, so to check our answer, we're going to plug in x equals 4 over 5 here. And so we've got 2 times 4 over 5 plus 3 equals 7 minus 3 times 4 over 5. Okay. So this is essentially multiplying fractions, right? 2 over 1. And then again, multiplying fractions. But in order to combine these to see if they're equal, of course you could use your calculator, but I want to practice using fractions. we need that common denominator, right? So what we have is we have 8 over 5 plus 3 is 7 minus 3 times 4 is 12 over 5. I need that common denominator of 5, so I've got 8 over 5 plus 3 times 5 over 5 is 7 times 5 over 5 minus 12 over 5. Right? Remembering that trick to get that common denominator, because if we're adding or subtracting fractions, we have to have that common denominator, right? And so we have 8 plus 15 over 5. Hopefully, I guess we're checking, hopefully it equals 7 times 5 is 35 over 5 minus 12 over 5. Here, just to be sure, I'm going to use my calculator. And so I've got 8 plus 15 is 23 over 5. Hopefully that equals 35 minus 12. It does. 23 over 5. Right? Therefore, x equals 4 over 5 is the solution to 2x plus 3 equals 7 minus 3x. Nice. Okay. Good. So like I said, let's hold off on any more because it's more important that we get to quadratic equations. Okay, so quadratic equations have this form here, which we already kind of mentioned, but let's just write it out in general. So a quadratic equation is any equation where you have some a times x squared plus b times x plus c equals 0. Where a, b, and c are real numbers, and of course a can't be 0 because if a is 0, then there's no x squared term, and all of a sudden you just have bx plus c, which is not a quadratic anymore. So as long as you have an x squared term, you can call it a quadratic. Okay, and so what's nice about quadratic equations is that we're able to find solutions. We find solutions to quadratic equations using the quadratic formula. Which is on the next page, on the back page, if you have a physical copy, I guess. And notice, I'll admit, I am skipping kind of completing the square. It's going to come up later, so I will introduce it when we need it. But for right now, we need the quadratic formula to be able to factor quadratic equations and use it in 1.4. So the quadratic formula here is the moneymaker. So it says if you have something like ax squared plus bx plus c equals 0, as long as a is not 0, then a solution, or we're going to get two solutions potentially, is that x is going to be negative b, where the b is from here, plus minus the square root of b squared, minus 4 times a, whatever a is, times c, whatever c is, over 2a. Right, and so we pull this a, b, c from our quadratic formula, or our quadratic equation. Okay? So the roots are solutions. Okay. There are times where there will be no solutions, but we're not going to worry about that right now. Right? We're just going to kind of look at the quadratic formula. How can I use the quadratic formula to be able to factor stuff? Okay. So we use the quadratic formula to find solutions to ax squared plus bx plus c equals 0. Right? So we use the quadratic formula to find solutions, and then we use the solutions to factor ax squared plus bx plus c. To factor ax squared plus bx plus c. Okay. So what I want to do is I just want to show just quite a few examples actually, or they're pretty long, so just hang tight. All right, so we want to do, let's just skip straight to here. These guys, oops. So let's start nice and easy. And we'll start with 65, just to kind of get going. So 65 says x squared minus 2x minus 15 equals 0. Okay. This is a quadratic equation because I've got an x squared, I've got an x, and I've got a constant, and it's set equal to 0. There are times where you might have to rearrange things until you have a 0 on the right-hand side and everything else on the left-hand side. But for now, we're starting nice and slow, right? And so what I'm gonna do is I'm gonna highlight that, okay, if I just have x squared, that's really 1 times x squared. So this means that a is 1. Here, if I'm trying to match it to ax squared plus bx plus c, right? So if I'm trying to match it to ax squared plus bx plus c equals 0, well, that means that my b must be -2, and same thing with my c must be -15. Otherwise, they wouldn't be minus, right? Unless they were negative. So we can find solutions by using the quadratic formula. So the quadratic formula, and you'll probably end up memorizing this thing. I know it looks huge right now, but you will probably just end up memorizing it. You don't have to, you can, but definitely during a test or even during assignments, make sure you have the quadratic formula ready because it's going to be used a lot. So you've got x is -b plus minus the square root of b squared minus 4ac divided by 2a. Okay. So this becomes, so we pull our a, b's, and c's from our equation, right? So what I'm going to do is I'm just going to plug in our values and see what happens. So -2, make sure you keep that negative on there, it's really important. Plus minus the square root of negative 2 squared minus 4 times 1 times negative 15. All divided by, and make sure it's all divided by 2 times 1. One thing that I want you to check on your calculator is when you do negative 2 squared, if it gives you a negative 4, negative 2 squared, if I just do that on my calculator, trying to see here if I can kind of show you, right? It tells me that it's negative 4, but if I square a number, it's always going to be positive, right? So the problem is that I have to do square brackets negative 2 and bracket then to the power of 2, right? Then I get 4, right? So just make sure that if you're taking the square of a negative, you have to get a positive number, otherwise it's wrong. So this becomes, so negative 2 is 2 plus minus the square root of 4 minus 4 times negative 15. So 4 times negative 15 is negative 60. So minus negative 60 makes plus 60 divided by 2. One thing you want to be really careful of is, although it looks tempting to cancel this 2 and this 2, this root 4 plus 60 is also divided by 2. So you can't cancel that until you've pulled out a common factor of 2. So now we have 2 plus minus the square root of 64 divided by 2. The square root of 64 is 8. So I have 2 plus minus 8 divided by 2. This plus minus, right, and all along here, x equals, x equals, x equals, x equals. I just got lazy. If nothing's changing on a side, usually I'll just leave it until it changes. But I forgot that we're doing this kind of for the first time. So this means we will get 2 solutions. Okay. So it's going to look like x equals 2 plus 8 divided by 2, and x equals 2 minus 8 divided by 2. Okay. I'm still resisting the temptation of canceling a 2 here, right? I could, but I'm going to try not to because it just makes it a little bit cleaner later on. So what I have here is x is 2 plus 8 is 10 divided by 2, and x equals 2 minus 8 is negative 6 divided by 2. So x equals 5 and x equals negative 3 are solutions to, now where is that one that we're doing? To x squared minus 2x minus 15 equals 0. Okay. These are solutions, right? So we can check this, and we're not going to keep checking everything that we do, but I want to show you that you have the tools to be able to check your answers. So what this means is if I plug in x equals 5 here, it should equal 0. And same thing, if I plug in x equals negative 3, it should equal 0. We can check our work by saying, okay, well, 5 squared minus 2 times 5 minus 15, does it equal 0? So I put a little question mark up above the equal sign to say, hey, does it equal 0? I don't know yet. 5 squared is 25 minus 10 minus 15. Hey, it looks good, but I'm just going to check on my calculator. 25 minus 10 minus 15 is equal to 0. So therefore, x equals 5 is a solution. So now check x equals -3 for doing the same thing. So now I'm doing -3 squared minus 2 times -3 minus 15. Does it equal 0? -3 squared is 9. Minus 2 times -3, so plus 6 minus 15. 9 plus 6 minus 15. It does equal 0. Therefore, x equals -3 is a solution. Okay, so this green stuff is optional, right? This stuff where we're checking our work, that's optional, but I just want to show you that you can. Yeah. So what does it mean if x equals 5 and x equals -3 are solutions? Well, just as a side note, what does that look like graphically? So if you have an x squared, you have some sort of parabola like this. Now they could look like this or like this, it doesn't matter. And then maybe things have been shifted around on your axis. So what this means is that at x equals, I didn't draw it very well, did I? Here. Why did I have to move it over? Because this is at -3 and this is at 5. It's closer to the, that's correct. Yeah, so it just shows where it's going to cross the x-axis. There are times when you might have something that looks like this, right? Maybe you, oh, sorry. Maybe you have a parabola that looks like this, right? This would have no solutions. Okay. We'll talk about that more later, but for now, everything's going to have solutions. But if you're using the quadratic formula and you end up with a square root of a negative number, then you have no solutions. Okay. So this can happen, right? This would make no solutions. Otherwise, the solutions are just the x values that make it 0. Okay. So that's just a side note. Put that here. Side note. Okay. So now, what we can do to make factoring easier is we can use the solutions to develop our factors. To make factoring a quadratic equation, easier, we can use the solutions to develop our factors. Okay. So let's have a look at what we started with, right? We had x squared minus 2x minus 15 equals 0. Okay. Where x equals 5 and x equals -3 are solutions. Okay. So if I'm thinking about a factor, right, a factor of this thing, x squared minus 2x minus 15, is going to look something like, so a factor is going to look like x plus minus some number times x plus minus some number should equal 0. Okay. Remembering that if x equals 5 is a solution, and I need to make it equal to 0, then if I plug in x equals 5 over here, then x minus 5 would give me 0. 0 times anything is 0. So I use that trick, right? And I say, okay, well, I'm going to need x minus 5 here, because if I plug in x equals 5 here, 5 minus 5 equals 0, right? Making this whole thing true. Has to equal 0. 0 times anything is 0. I'm going to remove this just because it's a little bit messy. So what I do next is I have a look at x minus 3. Well, x minus 3 has to be a solution. So this x minus 3 has to go in place of this x. So in order to make x minus 3 be 0, I would have to have x plus 3. All right, so plus 3. Actually, I should do a different color. Maybe green. Oh, orange. So now, x minus 5, well, x equals 5 is still a solution here. 0 times 5 plus 3, 0 times 8 is still 0. Still fine. If x is negative 3, I get negative 3 minus 5, negative 8 times negative 3 plus 3 is 0. Negative 8 times 0 is still 0. So these are still solutions, and so we use those solutions to be able to create our factors, right? So therefore, we can say that x squared minus 2x minus 15 should equal x minus 5 times x plus 3, and all of them should equal 0. Let's check this, right? We can check, just like we did with our other factoring, we can check our factoring by expanding out to make sure that we get to the same spot. Yeah. We can check our work by expanding. And just so it's not so confusing, I'm going to leave that equals 0 out and just say that we've used the solutions to kind of leverage this factor. Now we want to make sure that, that these are equivalent. So I can expand this, and hopefully I end up at this with a little bit of work probably. So I can have x minus 5 times x plus 3. That's going to be, if I expand this, right, x times x is x squared. And probably from the other day, right, you remember you have to take x times 3, negative 5 times x, negative 5 times 3, x squared plus 3x minus 5x minus 15. Once I simplify, I get x squared. 3x minus 5x is negative 2x minus 15. Ta-da! So it worked out. So this is a trick that I rely on pretty heavily, right? And you will too, obviously, is that as long as we have a quadratic equation, I can use this quadratic formula to find the solutions, and then I can use the solutions to make my factors, right? So let's do another one. Let's see here. What one do we want to do? Let's do 70, because it doesn't just have, it has a 3 in front of the x squared, right? And so we're not just dealing with 1 anymore. So let's go ahead and do 70. Three x squared plus 7x plus 4 equals 0. Right. And what we want to do is find the solutions and factor 3x squared plus 7x plus 4. So I'm going a little bit off of the actual question, right? Because I'm adding that element of factoring. Okay, so in 3x squared plus 7x plus 4 equals 0, we've got a equals 3, b equals 7, and c equals 4. Okay. So now, just again, I'm going to go through, use the quadratic formula to find the solutions. I'm going to check those solutions, make sure that they work, and then I'm going to use the solutions to factor, right? And then the factors, I'm going to expand them just to make sure I get to the right place. This one's a little bit trickier when you expand it, but I'll show you the tricks. So you won't have to check your work, obviously, at every step, but because we're just starting this stuff, then may as well. Okay. So let's get started here. Our quadratic formula is x is negative b plus minus the square root of b squared minus 4ac all over 2a, keeping in mind that it's all over 2a. Plugging in our values of a, b, and c, I get negative 7 plus minus the square root of 7 squared minus 4 times 3 times c, which is 4, all divided by 2 times 3. Okay. So I can simplify things a little bit. I get negative 7 plus minus the square root of 7 squared is 49 minus 4 times 3 times, 4 is 48. 49 minus 48, that's 1, so that's easy enough, right? Dangerously close to getting a negative, right? You don't want to have negatives in there, then there are no solutions. Divided by 6. 2 times 3 is 6. So now I have negative 7 plus minus the square root of 1 over 6, which is going to be negative 7 plus minus 1, just showing all the steps here, divided by 6. So x equals negative 7 plus 1 divided by 6, and x equals negative 7 minus 1 divided by 6. Okay. So I can simplify this. X is negative 7 plus 1. Definitely go ahead and use your calculator if you're not feeling comfortable, especially dealing with negatives. I want you to just make sure that you don't make any silly mistakes. So you're definitely better off just using your calculator, even if it feels silly sometimes. -7 plus 1 is -6, right? So -6 divided by 6 should be -1. And, right, there's going to be two solutions. X is -7 minus 1, which is -8, divided by 6. Especially if you've got a fancy calculator, something like this one, -8 divided by 6, it'll just simplify it for you. So you've got -4/3, or X is -4/3 if you're simplified. Either way, it doesn't matter. Simplified is easier to deal with, but if your calculator doesn't do it for you, then it doesn't matter. Okay. Now we've got our two solutions. I'm going to go ahead and use the simplified one. And to check my work, I'm just going to quickly plug it into the equation just to make sure that it is a solution. It is, I promise, but we can check our work. Right. So if I plug in X equals -1 into here, it should equal 0. And to save myself some memorizing here, copy. So if I let X equal -1, then I get 3 times -1 squared plus 7 times -1 plus 4. Does it equal 0? 3 times -1 squared is 3. 3 minus 7 plus 4 equals 0. So that's good. Now I'm going to let X be -4/3. And I have that fraction now. 3 times -4/3 squared plus 7 times -4/3 plus 4. Does it equal 0? Yuck. We can do it, right? Notice that, okay, I can bring in this square inside because I'm just dividing in here. So I can do that. Another thing I can do is I can treat this later as a fraction times a fraction times a fraction. So here we go. 3 times -4 squared over 3 squared plus, and then 7 times -4, I'm just going to do this kind of lopsided. 7 times -4 is -28 divided by 3 plus 4. Does it equal 0? I've got a 3 here and a 3 squared down here, and because they're being multiplied, I'm able to cancel these. So I'll highlight that, but it's only going to cancel the square there. Okay. So this is still going to be over 3, and this is over 3, and it's going to make life easier if I just put this over 3 as well. So, whoops, because I'm in green here. So I've got -4 squared is 16 divided by 3 minus 28/3 plus 4 times 3/3. Does it equal 0? So we've got a common denominator now because I forced it, right? All over 3. So now I can do 16 minus 28 plus 12. 16 minus 28 plus 12 all over 3. Does it equal 0? 16 minus 28 plus 12 is 0. 0 divided by 3 is 0. So a little bit longer, right? Than this one, this first one that we did, where it just, oh yeah, 0 falls out. Here we had to work for a little bit. We had to make use of things like multiplying fractions, adding and subtracting fractions, right? So we need to be really, really good at all that kind of stuff. And then eventually 0 divided by 3 is 0. So they're both actual solutions. Now let's do the same thing, right? To factor 3x squared plus 7x plus 4, we use the solutions. We use the solutions to 3x squared plus 7x plus 4 equals 0. Okay. So we have those solutions, right? The solutions are x equals, was it? Yeah, -1 and x equals -4/3. Okay. So what we're going to do is we want to factor 3x squared plus 7x plus 4. Notice the difference here. Equals 0, here I don't have equals 0, right? I'm just trying to factor this thing. Okay. 3x squared plus 7x plus 4 is going to be x plus minus something times x plus minus something, right, once I factor. Again, I'm going to use these solutions and do x plus 1, right? Because x plus 1 has to be a solution. X equals -1 has to be a solution. And x plus 4/3, because x is equal to -4/3, has to be a solution still. So what we do is we have x plus 1, x plus 4/3. Maybe I'll make this bigger. There. Right, so we use our solutions to make our factor. Now, again, it's going to be a little bit more work, right? But what we're going to do is we're going to expand this to make sure that we get to this same spot. And like I said, there's a little trick at the end that we have to use, but it will work. Okay. Oh yeah, so expand this to check our work. So if we have to expand, I'll keep it in green maybe, x plus 1 times x plus 4/3. Sorry, I've got a tickle. So start trying to expand that. Don't be scared of that fraction. Okay. So I've got x squared. X times x is x squared. X times 4/3, so plus 4/3x. Usually I like to have my x on the right-hand side. 4/3x plus x plus 4/3. This looks nothing like this, but after we rework it, remembering how to deal with fractions, right? We can combine these like terms. by putting this x over a common denominator of 3, and then we're able to combine these. And so what we get is we have x squared plus 4 over 3x plus x times 3 over 3 plus 4 over 3. So now I've got 4x plus 3x all over 3, right? I'm going to pick it up a little bit, pick up the pace. So I get x squared plus 7x all over 3 plus 4 over 3. And you'll want to make sure that you got that jump, that leap. So now I have 7x and 4 both over 3. The only thing that's not over 3 is this x squared, but I can use that same trick and I can multiply x squared by 3 over 3 to get that common denominator. So x squared times 3 over 3 plus 7x over 3 plus 4 over 3 puts me at 3x squared plus 7x plus 4 over 3, all over 3. Hey, close, right? What we need to remember though is that because this is all equal to 0, right, then this 3 can kind of get multiplied away into the 0. 0 times 3 makes 0 still. So even if I multiply this over, then I'm still safe. And I know that's a weird, right? 3x squared plus 7x plus 4 equals 0, right? Which is going to be 3x squared plus 7x plus 4 over 3. Well, if I take this 3 and I multiply it into 0, eventually I get 3x squared plus 7x plus 4 equals 0, which is also equal to 3x squared plus 7x plus 4. And I know that's weird, but that's how we get there. Okay, good. Let's see here. Okay, how are we doing? Oh, shoot. Okay, so let's get back into 1.4 and see how we use this to set up our factors of a quadratic equation. So step 1, recognize a quadratic equation. Step 2, use the quadratic formula to find the solutions. Step 3, you have to use those solutions to set up your factors, right? So now, we will return to section 1.4 and use the trick of factoring quadratics we just learned. So if I go into 1.4, back into 1.4, right, we talked about the domain, fine. That was last day. Then we said, okay, well, I can simplify algebraic expressions, right? So if I have a rational expression, then this could be, you know, something nasty like this here, where it doesn't have to just be numbers now. I can still treat them like fractions, as if they're fractions. I just have to be careful when I'm expanding or factoring and trying to simplify. So the first one we'll do is Let's do number 15, just to start slow. Now, notice that I've crossed out this 24. I mentioned it earlier, but it's because it had an x to the 3 in there, and we don't need to know how to do that. So all of these just have a maximum degree of 2, incorporating our polynomials, right? So let's do 15 together. 15 has 5 times x minus 3 times 2x plus 1 divided by 10 times x minus 3 squared. Okay, so I see that I'm multiplying and multiplying across the numerator and the denominator. So I'll be able to cancel stuff as long as I'm just multiplying and dividing. So I've got an x minus 3 and an x minus 3 squared down here. I'm going to rewrite this x minus 3 squared as x minus 3 times x minus 3 to really illustrate that I'm actually breaking out this common factor, and then I'm able to cancel. As well as the 10. The 10 I'm going to rewrite as 2 times 5 to be able to cancel with this 5 up here. So you're just scanning for things that you could pull out to make this simplified. So this becomes 5 times x minus 3 times 2x plus 1. Now I'm not really doing anything, I'm not doing anything to the top, but I am rewriting 10 as 5 times 2 times x minus 3 times x minus 3. X minus 3 squared is x minus 3 times x minus 3. You want to be careful. Now, 5 cancels with the 5. As long as you're only multiplying across, you're allowed to do that. X minus 3 can cancel with one of these x minus 3's. And as far as I can tell, that's all I'm able to do to simplify this thing. So now I'm going to rewrite this as 2x plus 1 divided by 2 times x minus 3. The only thing I could do is I could expand this 2 into the x minus 3, which I'll do just to make it look nicer. 2x plus 1 divided by 2x minus 6. And that's simplified. You cannot cancel a 2x, even though it looks tempting, right? But because 2x plus 1 is being divided by 2x minus 6, you can't pick and choose, right? You have to be able to pull out a common multiple in order to be able to cancel. So that's it for that one. Let's do, let's do 18 together. My dog is telling me she's done with teaching. Usually she just, she lays on a chair right there, well, like behind you guys. And she's a bad girl. And when I'm just talking, she just kind of falls asleep like this. I'm sure she's not alone. Bella, stop it. She's really tiny too, so sometimes she'll do like, I know, I'm a bad dog mom because I think it's really funny when she goes, wah, rah, rah, rah. Anyways, let's do 18 and call it a day. How about that? The dog has called it. 18 is x squared minus x minus 2 divided by x squared minus 1. Now, there are a couple of things that we can do, right? Definitely, if I want to simplify this thing, then I'm going to make use of factoring, right? But I'm going to factor this top portion, so the numerator, And I'm going to factor this denominator, and hopefully I'll be able to shake some things out that I'm able to cancel. So looking at this here, you want to run through your toolkit of factoring, right? So is there a common factor you can pull out? Is there, are there more than 4 terms? Then you could do some grouping maybe. Some things we learned last day. What are some other things? Oh yeah, the special factoring formulas. Or do you have a quadratic? Then you can just use the quadratic formula. So here, what I'm going to do is, this is a quadratic. This is also a quadratic. Or if you prefer to use the special factoring formulas, you could do that as well, as long as you treat 1 as 1 squared. So from the top, you could, but it doesn't actually get you anywhere, because if you do x times x minus 1 minus 2, then you can't really do that unless you have more than 4 terms, right? So yeah, it doesn't really get you anywhere, but what I do want to emphasize is don't be afraid to try stuff. There's no harm in trying stuff. Sometimes it might work, right? You might head down a way dead end, but that's how you learn, right? To recognize, oh, that didn't work last time, right? And then you can kind of get to results that way. So the x squared minus 1 is a quadratic, but it's also a special factoring one, right? X squared minus 1 squared, you could treat it as like that. Special factor. If you have x squared minus 1 squared. I'm going to use the quadratic just to show you what it looks like when you don't have, when b is 0, right? So we factor these individually, right? We factor the numerator and the denominator individually, and then hopefully we're able to cancel after. So we factor the numerator and denominator individually. So for the first one, right, x squared minus x minus 2, I'm going to look here and I've got a equals 1, b equals negative 1, and c equals negative 2. Notice that I don't have equals 0 here, but that's okay. I'm going to pretend there's an equals 0, figure out the solutions, and then use those solutions to factor, right? So I have x is going to be negative b plus minus the square root of b squared minus 4ac over 2a. It's always a really good idea to just write out the blank formula, even though it gets boring and whatever, and just write it out and fill it in every time. So negative b is negative negative 1 plus minus the square root of negative 1 squared minus 4 times 1 times negative 2. So now I have divided by 2 times 1. So I have negative negative 1 is 1. 1 plus minus, so I am picking up my speed a little bit here. So hopefully that is going to be okay. Negative 1 squared is 1 minus 4 times negative 2 is 8. So, or plus 8. So 1 plus 8 is 9. The square root of 9 is 3. Divided by 2. So x is going to be 1 plus 3 divided by 2, and x is going to be 1 minus 3 divided by 2. So x is going to be 4 divided by 2, and x is 1 minus 3 is negative 2 divided by 2 is negative 1. So we can write x squared, where are we here? Oh yeah, 18. X squared minus x minus 2 factored, and you can go ahead and check your work later, but now I'm doing it, right? Is going to be x minus 2 times x plus 1, right? Minus 2 because if x is equal to plus 2, it has to be 0, and x plus 1 because if x is equal to negative 1, it has to be 0. Okay, I factored. You can expand it and check it, but I'll leave that to you guys. So now factor x squared minus 1. If x squared minus 1, I have a is 1, b is 0, and c is negative 1. Or you can use that special factoring formula. But like I said, I don't like to have to remember all those. So if I see a quadratic, I'm going to use the quadratic formula. Yeah. And x is negative b plus minus the square root of b squared, b squared minus 4ac over 2a. So x is negative 0 plus minus the square root of 0 squared minus 4 times 1 times negative 1 divided by 2 times 1. Okay, so x is going to be 0. Negative 0 is 0. Plus minus, okay, negative 4 times negative 1 is 4. 0 plus 4 is 4. The square root of 4 is 2. Divided by 2. So x is going to be 0 plus 2 divided by 2, and x is going to be 0 minus 2 divided by 2. So x is 0 plus 2 is 2, divided by 2 is 1, and x is 0 minus 2 is negative 2, divided by 2 is negative 1. Therefore, the factored version of x squared minus 1 is going to be x minus 1 times x plus 1, which is what you would have gotten if you used those special factoring formulas. Okay. So now we combine these factored formulas or factored equations. I should say expressions. Why should I say expressions? An equation has an equal sign, right? Factored expressions and try to cancel. So what I have is I have x squared minus x minus 2 divided by x squared minus 1. Well, if I write these out as factored, for the top one, right, I had x minus 2 times x plus 1, x minus 2 times x plus 1, divided by, and then the bottom one was x minus 1 times x plus 1. Hey, what do you know? X plus 1 can cancel with x plus 1 because they're multiplying across here. How nice is that? So now we've simplified, and we can say that x squared minus x minus 2 over x squared minus 1, we can simply rewrite it as x minus 2 over x minus 1. Yay! I'll even put a smiley face. We did it. So we'll keep working on this next day, right? Any questions? No questions. I'll stay on the line for a little bit longer, but I'll stop the recording. And then if you don't have any questions, I'll see you guys next day.